This stage we are going to start the chapter kinematics. Kinematics actually having with the differentiation and integration part for a moving particle, especially to know the displacement, velocity, acceleration. We need to use the kinematics. So let we see the what the part for the introduction. It is written here in this book. This is a velocity time graph is given there, distance time graph is given there. So from a distance time graph can be used to find out how the distance changes with time. The gradient with distance time graph represents the speed. So in the first part, the straight line shows that the speed is constant in that stage and steady speed till to the straight line. And from this point, say if we mark the point A, this is the point B, and last point is BC. And horizontal line shows that the speed is zero. Yeah, so speed is not increasing, so speed is zero. There is no distance traveled by this particle in this time. And the steeper part of the line is greater the speed. Speed is greater than the way part. It is mentioning here that thing. And the speed time graph can be used to find the speed changes with time. The gradient of the speed time graph and the area under the speed time graph represent the distance traveled. So let us see another curve equation from the speed time graph. This is speed time graph. Speed time graph is given here. Here the line with positive gradient means the speed is increasing. From if we can mark also way B, C, say that the 1, 2, 3, 4 stage of the speed time graph. First stage is it is increasing. Second stage is the line with zero gradient means speed is constant. There is no increases of the speed. And the third stage of the steeper the line, the greater of the acceleration. So BC part acceleration is more than the OA part, it is written here. And the line with the negative gradient means the speed is decreasing. Last part of the speed time graph, CD part, showing that one. And we needed to know while we're doing the kinematics, especially the what is the scalar quantity and what is the vector quantity. Scalar quantity, distance and speed are examples of the scalar quantity which presenting only the magnitude. Scalar quantities have magnitude but no directions. This is the difference with the vector quantity. And in this book, we are going to discuss spatially displacement, velocity, and acceleration are the examples of the vector quantity. Vector quantities have magnitude and the direction. This is the difference between scalar and magnitude because we need to apply both of the things here. But especially while we are differentiation, this three displacement from velocity to acceleration, we have to go. And displacement usually we are presenting with the expression with the s in terms of t, and it's a presentations are given with the graph. Here one graph is given 0 to 5, and displacement is showing here. Displacement time graph, the displacement time graph, we can find out the distance from here as well. So see, from here it is written there that represents the motion on a diagram. Actually why they have used this one, I'm going to represent. If you want to get the total distance, so from 0 to till to 4, it travels a distance of 4 meter. Okay, this is the first stage. And from 4 to minus 5, actually it is traveling that displacement. So total is 4 to minus 5, which is 9 meter. So if anyone asks you from 0 to 5 second what is the distance it crosses, then we have to add 9 plus 4, which gives us 13 meter. But if you wanted to know any displacement in any particular point, then you can use the equation. If you put the value directly, then you get the displacement. Say at the point of 4, what is the displacement? We can say displacement is 0. At the point of 5, what is the displacement? The displacement is minus 5. At the point of 2, what is the displacement? Then you can say displacement is 4 meter. This is the 4 meter. At the point of 3, say if anyone asks is what is the displacement, then you can say displacement is 3 meter. But the distance is different thing. Distance is the total distance traveled. what is the turning point we need to take in consideration in that case. And what I discussed, it is written here completely. And another part, sorry, velocity and acceleration is another part. Velocity we would get if we differentiate the part of the displacement, then we would get velocity directly. And this is called the expression of the velocity. And another thing, acceleration. What is the acceleration? Acceleration, if we differentiate the part velocity or double differentiate of the displacement, then we would get the acceleration part and expression of the acceleration. This is the total of the kinematics in this chapter. And another important thing from the displacement is, I'm going to write the thing. S stands for displacement. And from here, if we want to go the velocity, this is called the velocity, all of the vector quantities. And from velocity we would go acceleration. We can write here acceleration, and always we needed to differentiate in that part. d by dt of s, d by dt of s gives us this velocity, and if we differentiate d by dt of velocity, then we would get the acceleration. Hope it is clear. But if we wanted to go to the reverse direction from here to there, say from acceleration to velocity, then we need to integrate of the acceleration with respect to dt, definitely, then we get the velocity. And from velocity to displacement, if we wanted to go, then we can write here s equals to integration of velocity dt, then we get the displacement part. So this is actually the opposite direction. From displacement, velocity, acceleration, if we wanted to go, we need to apply the differentiation. But in that stage, if we go or wanted to go reverse from acceleration to velocity, we have to integrate, and velocity to displacement we needed to integrate. This is the total of the kinematics basic information to going to start. Let's jump to the exercise to do the questions.